So we've got fusion reaction occurring when two protons fuse together to form a hydrogen-2 nucleus. And it wants us to calculate the binding energy per nucleon in mega-electron volts of the hydrogen-2 nucleus. And it's told us the mass of the hydrogen nucleus is 2.0135 U. Alright, so let's jump across. And so what we've got to do then is work out this binding energy. Now to do that, what we're going to need to know is the rest mass of a proton, the rest mass of a neutron, and we're going to want to know how we convert from U across to mega electron volts, which is that scaling factor there. So if I go through this, I'll see what I'm doing. First off, it said that one atomic mass unit, 1 U, is equivalent to 931 mega electron volts. So that's what I've written down because I can remember. The rest mass of a proton is 1.00728 U. And the neutron rest mass, it says, is 1.00867 U. Alright, so they're basically straight from our formula sheet. Now we should have everything we need. So my binding energy is going to be the rest mass of my components, so the rest energy, minus the actual observed energy or mass. So actual energy or mass. So if I look at it, what that's going to be, well, my rest energy would normally be of the constituents, so I should say of constituents, actual energy observed of it. So my rest energy of my constituents is going to be the rest energy of 1 proton plus 1 neutron. So it's going to be 1.00728 plus 1.00, oops, put the point in there, 1.00867, and that's U. So that's my rest energy of the constituents. And they told us in the question that the actual rest mass of a hydrogen-2 nucleus is 2.01355 U. So what we're really doing here is finding out what's the mass defect, the energy, the energy that's been lost, which is seen as mass. So effectively the mass that's lost as this fusion actually happens. So if I figure out what that is, I'm going to do, shove the numbers in the calculator. I've got, turn on helps, 1.00728 plus 1.00867, and that's all U, times by 2.01355, gives me 2.4 times 10 to the minus 3 U. So that's my binding energy of this nucleus in terms of mass. So then if I'm going to convert that across then, so to convert that, that's going to be 2.4 times 10 to the minus 3. Now I want it in mega electron-volts, so I can do times by 931.5 mega electron volts, which is going to equate to multiplied by 931.5 gives me 2.2356 mega electron volts. Now, at the very start, what it says, it wanted the binding energy per nucleon. So that's my binding energy. My binding energy per nucleon, therefore, is going to be 2.2356 divided by 2, because there are 2 nucleons, 1 proton, 1 neutron. So I divide that by 2, gives me 1.1178 mega electron volts. Now, if I look through here, they gave me everything to 1, 2, 3, 4, 5, 6 significant places. Sorry, significant figures. 1, 2, 3. So the most I've got is 1, 2, 3, 4 is my least number of significant figures. So therefore, my answer is going to be 1.118 mega electron volts, quoted to 4 significant figures. Hope that helps. Thank you very much.